I am going to do, I will launch my Prota software now. I will double click on it. I'm sorry, I'm using Prota Structure 2021. Then we will exercise patient also in order for it to open the Prota structure. Then carry another modeling in order to demonstrate in the Tekla text. So I am launching the software. We should exercise patience. It will open automatically. Then the portal it is opening. Then we will go and see and carry a moment at the support, and then come into the Tekla text, calculating order to verify or to have peace of mind whether such the design that the porter did for us is okay or there is some issue in the software actually. So it is launching. This is another BIM application. You can use the environment of the porter structure in order to do some detailing also. So it is opening. I'm just going to pick a member. Just after we pick the member and see the information on the member, the load acting on the member, the share, and everything on such member. And then we will just interrogate between such calculations from the porter and then the calculation in the Tekla text. So this is the structure that we work on it on the last week lecture. So I will click on this room automatically. I will go to the section that is the design of such section. I will click on OK. So if I click on OK, a dialog box will open with the information of such a BIM. So when I click, when I come here, if I check here, I will see the midspan moment automatically here, which is 539.45, and then I will see the moment at the support at that position, and here it is the thickness of the member, that is the cross section of the member. But if I want to view everything, I will click on BIM. If I click on BIM, a dialog box will open like this. I will double click here as I have explained in the previous lecture. And then I will see the moment here, which is 109.8. And the moment here, it is 150.2. That is the moment here. So let us take this moment, and we know the cross section of such BIM, which is when you come back here, let us click on OK. Let us come back to the bar. We know the size of the section, it is 225 by 650. And then we have 4x16. Then let us go into our Tekla test in order to compare the result that we get from the Prota structure and then using the Tekla test. So what I am going to do, I will just click on this dialog box, and then I will launch my Tekla text. Then I will click on this one again. Then I will exercise patience for it to open. When it's open, just for a few seconds, when it's open, then we will start the new project in order to demonstrate much more for you to understand. As we did on the previous lecture, we just assume some loads on it. Then now we are going to take the actual information of the structural member in order to calculate everything automatically and see the difference between them and which one will give us a best result on such software. We should exercise patience. It is opening. Okay, it is opening now. I will close this one. Then it is launching. I will click on new project. When I click on new project, then a dialog box will open again. For those of you that are joining the lecture now, also you will understand what we did on the previous lecture. So after then, I will come here and click on concrete, double click. I will find RC beam, this one, double click here and double click on this one automatically. So if I click on such, the dialog box will open, or let me say the calculation sheet will open for me automatically in order to put all of the informations and find the number of reinforcement on such structural member. So when it's open, when we come back to our portal structure, this is the portal. I will come back to the section design. I will come back here and then I will double click here. I have the moment as 150.2, which is at the right hand side of the support. That is 150.2. And the momentary distribution, assume we don't have momentary distribution, and then let us check the shear that we have at that support. That is the shear that we have at that support. That is AS min top. Okay, let us come back to the beam. Now to check the loads, that is the loads and ends of the columns. Yes, the shear here, it is 139.4 kilonewton, and the shear at the left-hand side, it is 138. Here is 139. Then let us go with the maximum, that is 139.4. Then the number of top reinforcement, so let us go with 2, and then Y16 here automatically. Then here is okay. Then here at the bottom span reinforcement, so let us go with also let us go with the 4, and then the size, let us go with the Y16. And the beam details, that is the information, durability, 1 hour, and then let us go with the beam exposed to fire on all of the 3 sides. And then the section here, it is 225 by 650. Then the concrete cover, we are going to go with 25, and then with 25 also. Then the grade of the concrete, this is the grade of the steel. I'm going to go with 410. And then here I'm going to go with 410 also. If I click on OK, automatically I will see everything. So when you check here under 4Y16, area required is 758 millimeters square, and provided it is 804 millimeters square, which is okay. We have 4Y16. And then let us come back to the shear reinforcement. Let us check what we have on the portal structure in order to compare everything. On the portal structure, we have Y12, Y8 at 225 center to center. So let us check according to that 225 center to center. And then you see area required, it is 308 millimeters square, and provided it is 447 millimeters square, which is okay automatically. So you see, we integrate between the two softwares in order to see what we are going to have, and we carry the moment, which is 150.2, and it gives us 4Y16 is okay, but let us change it to 3 and see, it is not okay automatically. But when it is 4, then it satisfies such conditions. And when we come back here, when you see that is the moment, it used the moment at the support here, provided the reinforcement, which is the 4Y16. If you come back, it used this moment, come in, double click, it used this moment since it is large, and this is the moment here, 145.9, 150.2. It used this moment in order to provide the support reinforcement as the compression still at that position. And this is the area of the steel required, which is 758.54. And let us check on the Tekla text, it's 758 here millimeters square, but here it says 758.54, but in Tekla text says required it's 758, in which both the two softwares have integration, and our design is okay based on the informations that we have. So I will click on finish. Then you will see your result here automatically. Then if I come here, I click and then come back to print. If I click on print, then I can print this one, and then I will specify the locations. Then I will give it BIM 003. Since we have BIM 001, we have BIM 002. Then it gives us such informations. So I will close this one. I will close the dialog box. I am done with the portal structure. Then I will minimize from the software. And this is the BIM detailing automatically. Sorry, this is the BIM results. So in order to generate the reports, you can use this software. So thank you very much. So I don't know if there is any question you can ask in order to answer such a question for you. But if there is no any question, then we can call it a day in order for